So hello to everyone, here is Andrea, and in this video we're going to learn how to calculate percentiles and what actually percentiles are. So let's begin with that. Actually, percentiles are statistical indicators that are often used when reporting like the results of surveys or when telling about I don't know, characteristics of generic populations, or in which we usually have a very large number of samples or individuals. I don't know, depends on what you're looking at. But yeah, and you can use percentiles to basically identify and to describe specific portion of this sample population. So more precisely, a percentile corresponds to a specific value of an observable that we are interested in, or a statistical variable, below which a specific percentage of the population is located. So I can give you an example, which I think is clearer than the statistical definition of a percentile. Basically, let's assume that we have the distribution of, the height values of all the British people that are living in the UK right now. So we have, I don't know how many millions of data. So if I say that, for example, 175 centimeters is like the 75th percentiles, it means that the 75% of the population of that population is shorter than the value that I was looking at, which is 175 centimeters. And so that value corresponds to the 75th percentile. To calculate percentiles, it's really easy, and Python makes it easier, even easier, by providing a function called percentile, which is a Numpy function, and yeah, we will see how it works. It's really immediate, but before, I think it's better to understand how can we calculate manually the percentiles in order to better understand how then the function is actually working. So basically, to calculate percentiles, we have to first sort all the values that we collected from our population in an ascending order. Then what we have to do is to calculate the product between the rank, which is represented by the percentile, the number of the percentile that we are interested in, like, I don't know, the fifth percentiles or so on, divided by 100. And then we have basically to multiply this quantity by the size of the population, and we get a number, which we will call through, as you will see, we'll call it P, from product, let's say. And if this number is an integer, we have to just search the value in our distribution that is corresponding to that number. Like, for example, suppose that the product is, I don't know, for example, 10. So we will look for the 10th element in our sample population, and that value will correspond to our percentile. While if this product is not an integer, we have to, there are different methods, as we will see, especially with the Numpy function, but the basic strategy is to approximate the number to the nearest integer number, and then do the same procedure. So finding the corresponding element in the list containing all the sample population, all the values of the sample population. So let's begin with the code. As you will see, it's really easy. So the first things that we have to do is to import the libraries that we will use in this exercise. So I will first import numpy as numpy as np. Perfect. Then I will import also math. I will use it for rounding the not integer value of the product to the nearest integer. And then I will also import matplotlib, and we will use it for plotting our percentiles and the distribution in order to have a better understanding also from a graphical point of view of their meaning. So these are all the packages. Perfect. So let's begin with the first part. So now we're going to define a function that is doing basically what I just tell you, what I was just telling you. So all the different steps for calculating the percentiles. So let's make a comment. So defining a function for calculating percentiles. Okay, so I will call it my percentile, and this function will take as input the data, which is the distribution that I have, the distribution of values that I have, and the percentile that I'm interested in. So the first thing that we have to do is to evaluate the size of the population, which I will call n. And so n is equal to the length of our population, which is which corresponds to the variable data. Then we have to evaluate the product p, which, as I told you, is equal to n times the rank, which is the percentile, over 100. Sorry, yep. Okay. And now at this point we have to choose two different paths depending on p, whether p is a whole number or whether it is not. So let's suppose that first of all, how do we evaluate whether p is an integer or whether it is not? Well, there's a very practical method called is integer that gives you a true value if the variable that is applied to is an integer. So we can use it. So we can just instantiate an if statement. If p dot is integer. So in this case, if p is really an integer, the only thing that we have to do is to search for the pth element in the list. So we can just say return, and yeah, I still have to sort the list of values, so I can do it now. Sorted, which is the function that sort the list that you give it as input in ascending order, so data. And then I will have to search for the element in data that is corresponding to p, because in this case p, we already know that p is an integer. The only thing that I have to do is to convert p into an integer, because it is a whole number, but at this step it is evaluated here, so it will be a float number. A float number. Okay, and this was the first case. What about if p is not a whole number? So else, what we have to do, we have to round its value to the nearest integer. So again, sorted data, And as index this time we have, first of all we have to to round the value of p. So I can just use the function of math.ceil, which basically rounds up to the highest nearest integer, the value that you pass in. So p. And then we have also to subtract 1, because the indexing starts from 0. And then we have still to convert this value from float to int. Perfect. I think we're basically done. Oh, yeah, this is okay. And of course we have to specify return. Okay, so in this case, this is the function that we have. We can now try whether it works or not. To do that, we have to we need a distribution of values. So I will create a random distribution using the function random and rand_n, which basically just draws samples from a normal distribution. So I can call it dist, and this will be equal to numpy.random.rand_n, and I will just have to specify the size of my population. Let's go with 10,000. Perfect. I don't want it to calculate just one percentile, so I will define a list in which I will store all the values of the percentiles that I'm interested in calculating. I will call it index, and in index I will, let's try to calculate the 5th, the 25th, the 50th, 75th, and let's go with the 95th. Yeah, perfect. These are all the percentiles that I'm interested into. So now we have to evaluate these. So to do that, I will exploit list comprehension in order to create a list that contains the values of these percentiles. And basically with list comprehension, so I will just run the function for every value contained in this list here. So I will call the list containing the value of the percentile persfunc, since we are evaluating them with our function. So list comprehension, okay. So I am calling the function my percentile. Our distribution is called dist, and the value, the percentile that I'm interested into, it's I, and for I in index. So for every value containing index, this function will be repeated, and for each percentile will give the value corresponding to the desired percentile that I'm interested in. Okay, I think we are basically done with this first part. I can try to run the function and see persfunc. Let's see whether it works. Okay, these are the values. This is the 5th, the 25th, the 50th, the 75th, and the 95th percentile of my normal distribution of values. So now let's move on. Now that we know how to calculate percentiles by defining a custom function, let's say, I will show you how to do that with Numpy, and as you will see, it's a lot faster and easier. So let's comment a little bit. Sorry, what happened? Okay. Okay, using, let's say, yeah, using Numpy to calculate percentiles. Perfect. So it's the same basically, so I will just define another list called pers numpy this time, and I will exploit again list comprehension, but this time the function that I'm using within the list comprehension is called np.percentile, and it's very similar. It takes as input the sample distribution, which is this, and the value of the percentile that I'm interested in, which is again I. And then we can specify also, well, I can do it later, and yeah, and I is for I in, again, index. So we can specify other parameters in here, like the interpolation method, which is basically the method that this function is using for dealing with the case in which this value here is not a whole number. There are different possibilities, as you can see in the official documentation. Interpolation, you can have linear interpolation, and here it explains how the function does that. The lower, so it approximates to the lower nearest integer number, higher to the higher nearest integer number to the nearest, or it computes also the mean. So there are different possibilities. So in order to match what we did here, I will specify the interpolation with nearest, sorry, which is the one that we used here. So we should get the same results. Perfect. So we are basically done again. It was, as I told you, really fast with NumPy. We can print both the function in order to see whether they are actually yielding the same results. So pers function, and then pers NumPy. Let's see how they looks like. Oh yeah, they are the same, as you can see, for all the values that they are identical. Perfect. And yeah, if you were to use other methods, basically the results would have been the same, or very, I mean, you may get very close results, but it's not a significant difference actually. Okay, perfect. The last thing that I wanted to show you is how to represent the percentile. Sorry, again, how to represent, I was saying, the percentiles graphically. So yeah, I can say plotting. So we can first of all plot the distribution. So plt.hist, which creates a histogram of our sample distribution. So dist, and I will also specify the number of bins to use, so 50. Then I will basically draw a vertical line for each percentile that I have calculated. So I can create a for loop for I in, and so I will have to iterate the procedure for all the elements in index. So range len index. Perfect. So what should we do? We should draw a vertical line, as I said. So we can do it by using this function here, axxvline, which draws a vertical line, and we have to specify a which value, and the value to which we have to draw a vertical line is, let's bring it to from the pers function list, and the element is I. And I can specify also the color, so red, for example. Okay, perfect. Yeah, and we're done. plt.show, and I will show you the results. Here we are. These are all the percentiles that we have calculated. As you can see, for example, the 50th percentile is corresponding to quite the middle value of the population. Of course, it's not perfectly zero because we are drawing the values randomly, so it's not perfectly centered on zero, but it's the value below which we have the 50% of the population. This is corresponding to the 95th percentiles, and so below this value, which is, I don't know, let me just remove it, more or less 1.6, and below this value we can find the 95% of the sample population. So this was just to give you an additional idea about what percentiles are and what they are used for and what they actually represent. I think that was it. Hope you liked the video, and yeah, see you in another one. Bye.